Good morning, students. How are you? Okay, now continuing with our life cycle models. We learn about the some life cycle models, our classical waterfall model, iterative model, and prototyping model on our previous classes. Now, moving on to the evolutionary model. Evolutionary model has many features of the incremental model. We know and we studied about the shortcomings of all the models, the classical waterfall model, iterative waterfall model, and prototyping models. In case of incremental model, software is developed over a number of increments. At each increment, a concept is developed and then successively refined and enriched for more functionalities until a full software is realized. The name itself, the evolutionary model, from the name itself, it conveys its principal idea. That is, the software is formed through various evolutions. But there is some difference between the incremental model and the evolutionary model. In the evolutionary model, the requirements, plans, estimates, and solution evolve over several iterations rather than the fully defined and frozen plans. Such evolutions are consistent, and in one sense, evolutionary model is an extension of the waterfall model. But even there is a shift in its major paradigm. So, for this reason, the evolutionary software development process is sometimes referred as design a little, build a little, and deploy a little model. This means after gathering the requirements, all these processes, the design, building, testing, and deployment activities are iterated. So, when we see the life cycle activities of an evolutionary life cycle model, in the evolutionary life cycle model, the software requirement is first broken down into several modules. Modules are certain functional units of the software. And these modules are incrementally constructed and delivered to the customer. So, the first task in evolutionary development model is to identify the core modules. The first task associated with the model is to identify the core modules. So, what is a core module? Core modules are the most independent modules in a software. The modules in the software that can function without communicating or without depending on the other modules, that are called the core modules. So, first we identify the core modules of the software, then all these functionalities are developed, and once the core modules are formed, additional functionalities are successively or incrementally added to these modules. So, this forms the incremental software development model. So, the development team first develops the core modules of the system. As I said, the core modules are the individual modules that do not need service from the other modules. They are independent individual modules that do not need service from the other modules. On the other hand, non-core modules need service from the core modules. Here in the figure itself, it is given that A, B, C are modules of a software product that are incrementally developed and delivered. So, identifying the core modules and developing that core modules, and then Other functionalities are incrementally developed and delivered to the customer. So, the initial product skeleton is refined into increasing levels of capability by adding new functionalities in successive versions. So, after developing the core modules, additional functionalities that are needed for the software are incrementally added to that skeleton, basic skeleton. So, the basic skeleton is the core modules, and to that core modules, to that basic skeleton, the skeleton is further refined by adding more functionalities, and this is performed in an incremental way, not in a single step. And each evolutionary version may be developed using an iterative waterfall model of development. So, the basic iterative waterfall model forms the basis of the evolutionary model. Though evolutionary model depends on, or it is developed using the incremental method. The modules are developed using the incremental method, but the basis of the evolutionary model is the iterative waterfall model itself. Each successive version of the product is a fully functioning software, and it is capable of performing more work than the previous versions. So, after developing the core modules, additional functionalities are developed so that at each incremental step the software is capable of functioning more or performing more than that of the previous versions. So, that is given in your figure, identifying the modules and then adding additional functionalities to that module. Here the A is the first module, first core module that can be individually developed, and after developing the module A, additional functionalities or additional modules can be added to the basic A module. That is, we have added B to A, B may be some other module, and after implementing A and B, we further add more functionalities to the A and B modules. That is, we add C to A and B. A, B and C forms the modules of the software product. So, we need to split the software into separate modules and identify which of them will be the core modules, and identifying the core modules of the software is the first task associated with the evolutionary model. The working of the evolutionary model is given in the figure. As on any software development life cycle, we first have to realize or gather the requirement specification. Gathering the requirements from the customer, that forms the first step in any of the software development process. So, here also we gather the requirements from the customer, analyze the requirements and form a rough requirement specification based on the requirements. So, after gathering or after forming a rough requirement specification, then identify the core and other parts that is to be developed incrementally. So, after gathering the requirement specification, based on the requirement specification, we identify the core modules of the software. The core modules are the individual independent modules of that software. And after identifying the core modules and the non-core modules, now the development or the implementation of the core part is carried out. Develop the core part using an iterative waterfall model. Note that here the core part is developed using the iterative waterfall model. So, iterative waterfall model forms the basis for the evolutionary development model. And after developing the core part of the software, The software itself is given to the customer and collect customer feedback and modify the requirements. Here, after developing the core modules of the software, the core modules itself is given to the customer, and when the after checking, the customer gives the feedback, and based upon the customer's feedback, more modification or alteration of the requirements will be done. So collect the customer feedback and modify the requirements based on the customer feedback, and then based on this modified requirements, develop the next identified features using an iterative waterfall model. Again, the development is based on the iterative waterfall model, but in evolutionary development model, all the developmental activities are carried out iteratively and based on an incremental style. That means we are not going to develop a software in a single step, or the phases are not there should not be any strict phase entry and phase exit criteria. Here the phases of development are repeated until the customer is satisfied with the partially developed software. So the partially developed software is available for the customer, and he could use the partially developed software and he could make suggestions based on his working experience on that software. So as we know, the customers may not be aware of specifying all the requirements. They need their work to be automated, so they need go for a software development team. But then also they may not be capable of specifying all their requirements. So it forms a good thing to give the partially developed software to a customer, and when he experiences with the or when he uses the partially developed software, he can specify more requirements, or he could be aware of what is his actual requirements or what he expect from a software. So from that customer feedback, the development team can make further modifications to the requirement specification. Requirement specification forms the basis for all the development process, but requirements gathering and analysis should not be done in a single step. It forms the foremost process in all the development life cycle process, but the requirement specification should not be carried out in a single step. So this forms the advantage of the evolutionary model. That means we can collect the customer feedback, and depending upon the customer feedback, we can make further modifications on the requirement specification, and this facilitates the customer to know what he actually need from that software. He could specify more on that requirements, and based on that customer feedback, the next level is developed. The identified features from the customer feedback are developed further using the iterative waterfall model, and again that will be given back to the customer. So this next version, developed version of more features, will also be delivered to the customer. So this is carried out iteratively. That means this step is carried out repeatedly until the customer is satisfied with all the functionalities of the software. So after developing the next identified features using an iterative waterfall model, again the partially developed software will be given to the customer, and again the customer can make use of it, and the customer can form or he can identify further requirements. So after collecting the customer feedback, again in case of any modification if needed could be made on the requirement specification, and again the next identified features will be developed. So this is carried on repeatedly until the customer is satisfied with the partially developed software. And after all the features are complete, the fully developed software would be handed over to the customer. That means all the after identifying all after developing all the other features of the software, that means the actual core modules as well as the non-core modules are developed, and all the intercommunication between the core modules and the non-core modules are developed. And when all the features, all such developmental process are complete, the software will be delivered to the customer. And from there, the maintenance process begins. So this is the working model of the evolutionary software development model. As on any software development model, we form a rough requirement specification, but for other models, it should not be a rough specification. It should be a clear requirement specification, and based on the SRS document, a software development process begins. But on evolutionary model, first a rough requirement specification is formed. That means it provides provision for adding much more requirements at any stage of the development process. So based on that rough requirement specification, the development team identify the core part of a software. So this is an important step in which the important, more relevant and more independent core modules are identified, and these core modules are developed incrementally. And note that is developed incrementally, not in a single step. And the developed core part is actually based on the iterative waterfall model. The core modules itself is developed using the iterative waterfall model, and after developing the core modules of the software, it will be handed over to the customer for his use. And after using the core parts of the software, the customer can identify his requirements, actual requirements. So collect customer feedback and modify the requirements, and then based on the customer feedback, develop the next identified features using the same iterative waterfall model. And when all these features are complete, these steps will be carried out repeatedly until this customer is fully satisfied with that product. Then all the other features, the development of non-core modules, all the intercommunications between the modules are developed fully, and when all these features are complete, the fully developed software will be submitted for the customer, delivered to the customer, and after that the maintenance process begins. So this is the working of the evolutionary developmental model. So the advantages of this model are: it forms an effective elicitation of actual customer requirements, because the customer can work with the partially developed system so that he could identify his actual requirements. So effective elicitation of actual customer requirements. This is the more important advantage of the evolutionary model, because the user gets a chance to experiment with a partially developed software much before the complete version of the system is released. Therefore, the evolutionary model helps to accurately specify user requirements during the delivery of different versions of the software. So the change request after delivery of a complete software becomes very less, because the customer gets chance to specify his requirements at each stage of the development. The change request after delivery of the complete software become very less. Also, the core modules get tested thoroughly, thereby reducing chances of errors in the core modules of the final product. Also, this model obviates the need to commit large resources in one go for the development of the system. So, this is an important advantage that the user can get a chance to experiment with the partially developed software. So, the software customer can specify his requirements in an actual practical sense, and it is easy to handle the change request. Handling change request is easier as no long-term plans are made in the system. As we said, the evolutionary model itself is said as a design a little, build a little, test a little, and deploy a little model. So there is no big fully defined plan for the system. So it is easy to make any change on any developmental phase of the system. Reworks required due to change request are normally much smaller compared to the sequential models. So change request can be easily done on the partially developed software. As the partially developed software is available for the customer, he could specify his requirements, and as there is no big plans completely defined plans for that development process, it is easy to handle the change request. It is easy to modify the partially developed software. So there is less chance of error because the core modules itself is developed using several iterations. There is less chance for errors, and it requires simple reworks based on the customer requirements. But there is some disadvantages with the evolutionary development model, because the feature division into incremental parts can be non-trivial. That means we have to identify the core parts of the software in this developmental model. But for some software, identifying the core modules is not at all an easy process. For some softwares, it cannot be possible to identify or split the software into several modules, individual or independent modules and dependent modules. So it is difficult for some specific softwares. It is difficult to divide the required features into several parts that can be incrementally implemented and delivered. So it could be used, this development process could be used for a specific range of softwares. That specific range of softwares that can be divided into or split up into certain core parts. And there is considerable effort to plan the incremental deliveries also. So this is not developed with a fully defined phase entry exit criteria. So there is considerable effort. Comparatively, the effort is higher than other developmental modules, because the plan should be, they should plan for the incremental deliveries. This is the most practical problem associated with the evolutionary model, that it is difficult to divide the problem into several versions that would be acceptable to the customer and which can be incrementally implemented and developed. So the evolutionary model is normally used for very large products, because the design can become ad hoc without specific attention being paid to maintainability and optimality. It could be these all criteria could be met only for large products, where it is easier to find modules for incremental implementation. Often this model can be used when the customer prefers to receive the product in increments. When the customer himself prefers to work with the partially developed system, this model is applicable for such situations. So that the customer can start using the different features as and when they are developed rather than waiting all the time for the full product to be developed and delivered. So it is the evolutionary development model is applicable only for large products where the product can be split into certain core and non-core modules, and for the situation where the customer actually needs to work with a partially developed software where he can specify the requirements or modify the requirements in several phases. So actually the evolutionary development model is appropriate for object oriented development project, because in object oriented development projects the system can easily be partitioned into individual units, core modules in terms of objects. So objects are more or less self-contained until that can be developed independently. So this is actually, it is helpful for large products, especially for the object oriented models. Okay, hope it is clear. So we shall continue with the other models on the next classes. Keep learning.